So on page 22, you guys, we already did that top problem. That's like what we just practiced on the next page. Then this is just what I want to work on today. It says if two functions, f of x and its inverse, or they say f and g are inverses, like which notation would you prefer? F and g are inverses, or f and f to the negative 1 are inverses? I prefer this because I don't like that exponent, but you can do either one. When you compose them, meaning f of g of x or g of f of x, when you plug g into f or when you plug f into g, you have to get x. And if you get x, then you know that you found the right inverse. And this is going to be a little funky, but I think you're going to be down with it. It says, given my function's this, find the inverse. Let's just start with that. What's the step to finding an inverse? Switch the x and the y. So what would the first step look like on this guy? If I switch the x and the y. X equals 4y minus 9. Get y by itself. What would we do to get y by itself first? Plus 9. You got it. Then what are we going to do? Divide by 4. And you guys, you could write x over 4 plus 9 over 4. Or you could write it as x plus 9 over 4. I don't care. Which one are you guys, do you think that you would typically do? Would you typically leave it like this? It doesn't matter. Or would you do x over 4 and 9 over 4? Just curious. How many people are left side? How many people are right-siders? Oh, interesting. We're kind of half and half. Well, either way, they're both right. So I'm going to show us both ways. This is the inverse. And it says, okay, to verify that they are inverses, I've got to go plug the inverse into f, and I need to just get x. I need to go plug this inverse, this one or this one, because they're the same thing. I need to plug this inverse into the function right here. And when I do, they need to cancel out just to get an x. Like what? So let me show you. If I said f of g of x, I'm going to say my inverse is g of x. I'm going to name my inverse g, and I now need to plug g into f. I need to go plug in g into f. Now you might be like, hold up. I'm plugging x plus 9 over 4 into x, and I'm going to say, yeah, because in inverses, the x and the y can switch. So if y equals this, I get to plug that in right there. If I plug that in, that would be 4 times x plus 9 over 4 minus 9. You see what I just did? I took my inverse, plugged it in right there, kept everything else alive. Does anything cancel if I multiply 4 times this thing? Wouldn't the 4's cancel? And then I'm left with x plus 9 minus 9. Do my plus 9 minus 9 cancel? And I'm just left with x. And that's what I needed for these to be inverses. I needed that. But we got to check it the other way too. We also have to check if we plug f into g. If we plug the original function into my inverse, I also have to get x. I need to go plug this original function into my inverse, and just to be, I'm going to put it into this one just to let you guys know you can do either option. You could plug it in right here for this x, or you could plug it into this x. Either way, it's all going to work out. We would have 4x minus 9 over 4 plus 9/4. I think this way is actually a little harder, because this way we got to separate it out anyway. This way we've got to say, all right, this guy minus that guy. We got to separate it out. So we'd have 4x over 4. Boop. We'd have 4x over 4 minus 9 over 4. I got that by going like this. Boom, boom, plus 9 over 4. What's going to happen with my negative 9/4, positive 9/4? What's going to happen with 4x over 4? And I'm just left with x. That's how I know I found the right inverse. Okay, let's practice this one more time. Ready? We got this function. Let's go find that inverse. Ooh! How do I find the inverse of this one? What's that first step going to be? Switching out the y and the x. So we got x equals y minus 3 cubed. Then what are we going to do? Yeah, let's go get my y by itself. X minus 4. I got to get rid of my cubed. What am I going to do? Cube root it. You got it. Do I need plus or minus with a cube root? No, ma'am. No, ma'am. You only need that plus or minus with our even exponent. not our odd exponent. Final answer, what is my inverse function going to be? Yeah, and just make sure that plus 3, you guys, is outside of my cube root. This is my inverse. I'm going to call that my inverse, or you could call it G, whichever you want to do. So that's step 1. And then look what they said. Verify that F and G are inverses. And how we do that is we got to go plug in G into F, my inverse into the function. Things have to simplify to get X. I got to go plug in my inverse, which was this little cutie, into my function right there. And things have to simplify. So let's do it. We'd say, all right, I've got, the cube root of X minus 4 plus 3. That was right here. I then need to do a minus 3 and put parentheses around that whole thing and cube it. So then I'd have a minus 3, parentheses around the whole thing, and cube it. Then I have a plus 4. Yes, you guys are so good. I saw you working. It was so good. Guys, can I cross out this cube and the cube root right now? Yeah. Not technically. What do I need to get rid of first? Exactly. So you're like, well, I knew 3 minus 3 was 0. So 3 minus 3 is 0. Now I can say, all right, a cube root and a cube do cancel each other out. And I'd be left with x minus 4 plus 4. Do things work out nicely? We get an x. So we proved it halfway. Bandy, I hope you use this time this weekend to get caught up on sleep and it cures you. All right, you guys, let's just do the opposite. We got to go plug in F into my X variable. We got to go plug in F into my inverse. Here we go. We've got a big old cube root now. This cube root's going to be huge. Instead of X, I got to put all this stuff. And I'd have an X minus 3, a cubed plus 4. Holy smokes. Under my cube root, I still have this minus 4. I still have that minus 4. And then outside the cube root, I have a plus 3. Whoa. Do things cancel nicely? What happens with 4 minus 4? 4 minus 4 is gone. What happens with my cube root of a cube? They cancel out, and I'm left with an x minus 3 plus 3, which is just x. Oops, I didn't record that. When we plug in our inverse, our function into our inverse, we also get x. This top guy. This was on the homework, but let's just do it so that we can practice things together. It says find the inverse. What's that first step to find the inverse, guys? Flip that x and the y, exactly. F of x is really just a y, so I'm going to flip them. I'm going to say x equals y minus 3 squared plus 7. That's our first step. We're going to flip the x and the y. The second step is to get y by itself. What are we going to do to get y by itself here? Minus 7. Then what do we do? Yes. Does anyone remember what we got to do with the square root? Plus or minus, which I often say plinus. And then let's get y all by itself. What would my inverse function be then? Yeah. Could I write that 3 in front and say 3 plus or minus square root of x minus 7? Either way. They're both right, and these are both the inverse. Okay, peeps, let's think about this real fast. They said, state whether the inverse is a function. Let's just go graph them both. This is just a sketch of them. Which way is this cute little parabola going? Cute little parabola is going which way? Up 7?
Yeah, and
right 3. So if I went right 3, up 7, here's my original parabola. Right 3, up 7. What's the inverse going to do? Yeah, that y equals x line. So all of my points would get flipped. I didn't know how to draw a lot of points because this was just a sketch. If this guy's origin was 3, 7, what's the inverse's origin going to be? 7, 3 is going to be the origin. So 7, 3 is maybe over here somewhere. And then, what's that going to look like? What's the square root graph look like? Right? What's the negative part of the square root graph look like? right? That's positive square root, that's negative square root. So this graph is just going to be like this, boop, that parabola on its side. And my question was, is the inverse a function? Said, no. Why not? Yeah, vertical line is going to hit that function twice. So that is not going to be a function. No, no.